Welcome to the the Academy Education Recitation. I'm a last-minute substitute. This was to be hosted by Luciana, who ably coordinates everything we do. And I just found somebody unplugged Spain. And I don't know how that's even possible in the modern era. But presumably we have to wait for somebody to Control Alt Delete the power system in Spain.
I just got a WhatsApp message from Luciana, Neil, that she indeed cannot make it. Neither can Santi. So good
That
replacement.
is crazy. I will fill in. So for the first topic, I'm happy to introduce Neil Gershenfeld. And I'm going to recap Academany. So once upon a time, Center for Bits and Atoms started with tools to make anything of any size. It would take too long to learn to use it, so we started how to make almost anything. The popularity of that started Fab Labs for outreach, and then I had remote students by video sit in on how to make almost anything, and eventually we started to have excuse me, more people remote connecting than in the class at MIT, and it became unbalanced. So we had the idea of starting Fab Academy, and the name initially was the Academy was going to be like a reference group of advisors, and it morphed into the class we now know and love, except when we hate it when there's too much work to do. It backed into an educational model of distributed rather than distance learning. So students with peers, mentors, machines, and work groups locally connected with global leaders and embraced a model of learning of just-in-time peer-to-peer project-based learning. And so we just did that to keep up. And one of the things we didn't expect were the network effects, that it's hard for any one site to do all of this. And it was much stronger to do it together than separately. And we didn't expect the kind of virtuous circle of the Fab Academy would train trainers, synthesize knowledge of the network. It was very much not center out, but collective from the network, and attracted, brought in, trained many of the leaders of the Fab Lab ecosystem and programs that have spun off. And so that grew into a much larger and much more important program than we ever expected. Then we didn't expect, but it grew into classes you'll hear about today: Bio Academy, Fab Academy, many others in this distributed global educational model. Looking ahead, all of the new classes are teams. Fab Academy is the last one and is now an outlier where I cover everything. And so this is the last year where I'll be the sort of the one-man marching band covering everything. And in future years, I'll still continue to be involved in coordinating, but it'll grow into a much larger team effort as part of that transition. And then I'm very involved in some of the newer initiatives you'll hear about towards the end. One is a Fab Futures initiative for 21st century vocational training. One is a distinct distributed incubator. And what's so interesting about those programs is they no longer have, roughly, they no longer have anything to do with access to a laser cutter. Until now, the class was defined by you needed the Fab Lab for the laser cutter. All of these classes span a much broader space of hardware and software. And for example, in the 21st century vocational skills, it's things like cybersecurity and data science, but they build on something even more important than the laser cutter, which is the community and culture we've created, and leveraging this for a global transformational educational platform. So finally, the name was given by one of my former students, Nadia Peak, who as a joke called it Academy of Almost Anything as this started to proliferate. And the Academy of Almost Anything got shortened to Academany. And so that's what Academany is, the educational program that grew out of Fab Academy and has gone far beyond it. So that's the intro. And now for the tour, and view this tour also as a shopping list of things you can do after Fab Academy and in parallel. Uh, and so with that, and for each person, let me know if you want me to screen share for you, if you want to take over. I'm delighted to hand off to Anastasia.
Thank you, Neil. I will present the Fab Academy, the Textile Technology Academy. I hope that you can hear me well. And I will be brief. This is the 9th year. Time flies. We are having this program very similar and based on the foundations that were set by the Fab Lab Network and the Fab Academy, also using the same infrastructures such as the evaluation system. There is some noise from someone.
Sorry, Tom,
There are
that's you.
some.
Tom, that's you. I muted you.
Yes, thank you. We have continuously labs that they are joining the program, meaning that they are expanding their inventory with textile equipment and biolab equipment. And up to now, up to today, we had around 180 applications, out of which there are around 30 labs that they made it. So we have from very early stage, from zero, to labs that they are already Fab labs and they want to expand to textile and material lab, or completely traditional textile labs that they want to become digital labs and implement the Fab lab. And we focus on 4 areas. First is sustainability. The second is Industry 4.0, 5.0, wearable technology, and innovation narratives. These are the 4 areas. The program is a little bit different than Fab Academy. It has 2 phases. The first phase is like Fab Academy, 13 weeks with different skills and machine training and topics. And the second phase is 3 months, 13 more weeks, which is the personal project development with personal mentorship, like a little bit like an incubator. And the program is trying to expand a little bit the spectrum and also make a very easy access to unbox the black box of technology for people that they are coming from a more artistic or more designer background. So it is oriented to fashion designers, scientists, craftspeople, industrial product designer, teachers. We have a lot of teachers, and also for people that they want to become lab managers for textile labs. We share the same values with the Fab Lab Network, which is the sustainability, the open source culture, the hybrid learning. We form also a part of the network. We bridge digital fabrication, textiles, and biology to novel career paths, and we are delivering this modular curricula. So after 9 editions, we had 330 people signing up. Not all of them graduated, of course. But these people, they are coming from different cultures, and they are also under this concept of under new technologies age. There is no age in taking the training. So we are talking about lifelong learning. And we are trying to bridge those different topics. So digital and craft literacy, making a textile lab network, and talking a lot about circular and eco design. I have a video to share, but maybe I am off time. So let me know if I can share it or not.
Let me mute. You're right on time. It'd be best if you could put a link in the chat. You're right on schedule for time.
Okay. Okay, so as a conclusion, I would like to say that we have been reflecting a lot to see how viable is to offer these programs, being part of the Academy and also continuing Fab Academy. We are for sure going to have the 9th edition and the 10th, but after the 10th, maybe we will reevaluate and consider what is the future of that. And also, we are considering a lot how the structure of documentation can become open access knowledge. So I am currently doing my PhD, researching on the impact of these 330 people that have signed up and what are the novel career paths and what are the future possibilities of diluting this knowledge to make it common sense to the society.
Great.
Yeah.
Okay, thank you, Anastasia. Next, David.
Okay, if I go full screen, does that work? Are you seeing full screen?
Yep, audio, video, and slide are all good.
Fantastic. So honored to be here with you all. I'm David Kong. I'm the director of the Community Biotechnology Initiative at the Media Lab. And for many, many years now, I forget even exactly which year, we've been working with Professor George Church, Joe Jacobson, and a really amazing crew of faculty on how to grow almost anything, aka Bio Academy. We also have a team-based model, and again, just really grateful to all of the faculty over the years, real leaders in the breadth of synthetic biology that have been participating. Very much structured like, I think, Fab Academy and also Fab Academy in terms of the learning model of weekly skills development and culminating in projects. One historical fact about how to grow almost anything Bio Academy, this actually started with the Fab Lab network. And so we started teaching it in a distributed global way. And then we actually went from this global model, starting with the Fab Lab network, back to MIT. And so we brought the course back to MIT right before the pandemic. And this would have been, and basically over the past handful of years, we've seen really tremendous growth and exponential growth even in the past year in terms of both our MIT Harvard students, but then in particular the global classroom, which has evolved over time with almost 1,300 accepted students last year, or actually in this current edition right now in the spring, and a growing network of nodes, which I'll talk about in a moment. We also, again, I think very much like the Fab Academy story, have this really amazing virtuous learning network of TAs, students that become TAs, TAs that also become faculty, which is a story that's happened for a number of folks. I think Thros is the one person that was a student TA and faculty member. Also, again, you don't need to have any bio background to participate in How to Grow, which is a big kind of low floors concept. And we start really from the very fundamentals if you don't know anything about biology. Go into principles and practices. This is George and Charles Darwin. So George is like the chiral Charles Darwin. Read, write, edit DNA. We spent a lot of time on lab automation, which has been an increasingly important topic. Protein design has been increasingly important as well. Obviously, everything that's happening in AI is something we spent a lot of time on in this particular module. AlphaFold 3, RF diffusion, all tools that the students work with in design of proteins to more sophisticated genetic circuits, cell-free systems, biological production. So there's a lot of biomanufacturing themes. Building large genomes. We have wildcard weeks where we explore a variety of topics depending on the year. Measurement and imaging, microbiome science, frugal science, biodesign, and even eco-augmentation. So there's a big span of different topics we cover, culminating again in the personally meaningful projects, demonstrating the ability to grow almost anything. Over the years, we've seen so many incredible projects. Again, Yishao, great story. Never been in a biolab, never been in a wet lab before. Later became the CEO of our own biotech company selling desktop biolabs. We get a lot of architecture students, urban planners. Projects become theses. This happens a lot. This is Eyal's project, which is now his PhD thesis. Computational projects, computationally designed enzymes, spider silk spacesuits. It's just an incredible array of projects. Last year we had some 10 hours worth of final project presentations. This year we're expecting more than that. Please join. It's actually really fun. So just a real amazing set of projects there. One note, during the pandemic, we were really forced to innovate. You couldn't be in a wet lab anymore, so we taught the students how to program robots. And so this has turned out to be a big inflection point, I think, historically for How to Grow. So you could, for example, be in your dorm room across the street or anywhere around the world, program robots at MIT, do your bioproduction homework, for example. And this got us into a distance model, distributed and distance model for education, where you could be almost anywhere. So how to grow almost anything, almost anywhere. And this, for us, I think, got us thinking about this cloud lab model for learning. And we published a paper in Nature about this, Nature Biotech. The majority of the students in this paper were, or the majority of the authors are students. The majority of the students had never been in a bio lab before taking the class, which for me, I thought was really great. So to get to this kind of idea of scale, we've been really leveraging and leaning into the robotics. And so we still have a node-based model, which is very much like, I think, the larger Fab Academy story. But what we do is each of the nodes, and we currently have nodes in New York, San Francisco, Quito, Ecuador, Victoria and Ottawa, Canada, London, South Korea, and in Tokyo. The nodes also take on virtual students. So if you're close enough to be in person, you go in person. If you're in the same time zone, you still do peer-based learning with the folks in your time zone and mediated through robots that can be controlled remotely. So that's kind of the model we've been building out. And again, it's been so great working with the virtual students. It's always mind-blowing to see which high school students all the way to retirees. And one big innovation for us started last year was this idea of network-wide projects. So all of the nodes collaborating together on a project. We did one on global health and phage therapy. So students designed lysis proteins. We tested those proteins locally at MIT with digital microfluidics. Each one of these pixels is a different protein design. And then they're being expressed cell-free. And then having the network of nodes with liquid handling robotics actually decentralized prototyping the proteins that way as well. And so there's kind of a larger architecture we've been really thinking about with this network of robots and distributed protocols and also best practices and also knowledge, inspiration, et cetera, that have been going through the network. This year, we started another project on neuromorphic circuits, which are these genetic circuits. You can put them into mammalian cells and they give kind of neural network-like behavior. Again, students all around the world designing circuits, programming robots, putting the circuits into cells. Doing biosecurity around that. And I'll close just by saying workforce development. Neil mentioned one of the big things there. It's an emerging area in the United States as well. Bipartisan commission just this month putting out this larger report on the importance of workforce development in biotech. And so we think How to Grow can really help fill that need. BioMade, they're an entity in the United States that supports this type of biomanufacturing capacity building. So we're building out additional nodes throughout the United States as part of a national network effort. And I've been built out this really epic industry council. This is 21 different companies across all kinds of spectrums of synthetic biology that are working with us on this. And so really excited about the industry engagement in this industry and council. And then again, grateful to Neil so much, Sherry, Mitch Resnick, Aman, helping us think about scalability, interactions with DoD, who's very supportive of this, and also kind of other learners and evaluations. So that's the whirlwind update, and so excited again to engage closely with all the students here, and would love to continue exploring how to collaborate more and have students join the course.
Good, great progress. Thank you, David. Fab Learn.
Hello all, happy to be here. I'm going to introduce Fab Academy. Actually, it should be Santi who should be here, but unfortunately, well, there is this blackout in Spain, so I will take his role, and I'm presenting one of the youngest program in the academy. Is this Fab Learning Academy, and this program was born like 3 years ago, and after a lot of discussion with teachers all around the world, we realized that there is an increasing efforts of integrating digital fabrication and makerspace into schools, into formal education. But the big challenge is that many of the teachers, they felt that they didn't have enough tools and enough support for this adoption. Actually, many of them complaining that they just give them the tools and say, okay, use them in your classes, but nobody give them support. There is no integration in the curriculum, and teachers they had to manage on their own. So after discussion, a lot of time of discussion, we came up with the concept of Fab Academy in order to give teachers the support that they need, not only in the technological aspect, but also in the pedagogical aspects of how to integrate these technologies into formal education, into everyday classes. And now we are our scope is teachers from kindergarten till high school. How are we doing? Well, we have built this model based on 3 pillars. First one is technology. Basically, all the tools that they can use in digital fabrication, all the process, but at the same time, within the intersection of science of learning, where we cover all the learning theories and especially aspects of the maker mindset that are a big a very important topic in the when we are trying to adopt these technologies and this process in schools. And then the third pillar is innovative practice, where we try to support teachers in lesson plan development, how to integrate this into their own classes, into the existing curriculum, best classroom practice, and also how they can work with other teachers and more other topics. So what is the idea? Since teachers, one of the complaints is when they were taking Fab Academy is that, okay, this is a lot of work for us. We don't have enough time, especially in service teachers. They couldn't keep the track of Fab Academy. We were discussing and we decided to reduce the workload of the participants to 4 to 6 hours per week. So they could take the program at the same time as they are working. So the program is divided. First, the global master class. So it's this meeting with all the participants all around the world, where we develop some of the topics, especially focus in the pedagogical aspect, not that much in the technological aspect. And then during the week, they have hands-on instruction with the local nodes, with the Fab Labs or maker spaces, where they are doing the Fab Learning Academy. Then we have these real-world talks that is similar to this, what we are doing here today, but more focusing in practitioners, teachers, and other experts in education. And then we also offer the opportunity for those who cannot follow the global master class, these asynchronous reading and videos. So the program is divided in, it takes six months and is divided in 4 modules. And the idea is that after each module, they will need to create a lesson plan and execute it in a real classroom environment. So it's not only that they need to prepare the lesson plan, in which they need to include some of the digital fabrication process that they have been working with during the previous week, but they also need to test it and evaluate it in a real school environment. Of course, they will receive help from the different nodes. And I'm going to explain a little bit which is the structure, because it's a little bit different than what we were used. We have what we call virtual hubs that they are focusing on, they are giving support to a set of physical nodes. These virtual hubs, they have experts in pedagogy, so they have had people that have been integrating digital fabrication and that have been supporting teachers for several years already, so they have experience. And the idea is that they provide this support in the pedagogical aspect that perhaps some of the labs and makerspace they don't have. And then we have physical nodes that are distributed around the world. We have in Asia, in Europe, Middle East, and America. So right now the academia is formed by a group of people that all of us have experience in digital fabrication. I guess all of us have taken Fab Academy, but at the same time we have a long experience working with schools and working with teachers. And I think that, well, you can see here a list of teachers that have been participated in the last 2 years and some of the projects that they have developed and tested in schools. We are still making few changes in the program. So we have just finished. Actually, we are evaluating the first official cohort of students, and based on their feedback, we are going to do a few changes. One of them is that, for example, participants who have been part of Fab Academy, we are going to decrease their workload in the sense that they don't need to come every week to the Fab Lab and work there. So if they have the concepts, I mean, how to use the different equipment, they don't need to come to the Fab Lab. They just need to come to the weekly classes, and then at the end of the module, they need to implement, with the support of the local node and the educational hubs, they need to implement the lesson plans as the rest of the students, and they need to evaluate what was the results. And I think that's all. So if you want to learn more, you have all the information in our website. Thank you.
Ivan, what has the feedback been like from the teachers? How well is this working to meet their needs?
In general, the feedback that we have had, we still need to do the final surveys and so on, but in general, the feedback have been very positive, especially they like a lot the global community. So, for example, we have in my educational hub, we have students or participants from Peru, from Iceland, and from Finland. And they consider very positive this discussion that we have every week with different schools of different parts of the world, and that they can see that they have common challenges but different solutions. So I think that this was one of the things that they like it most.
Okay, good. Okay, thank you for filling in on short notice, Ivan. We're on to Salman.
Can you hear me?
Yes.
Can you see the full screen?
Slide, audio, video are all good.
Okay. Hi, everyone. I'm Salman. I'm from Fab Lab Bahrain. Fab Lab Bahrain has completed 10 years as part of the global network of Fab Labs. Actually, we started back as a node in Fab Academy diploma. And through the years, we were part of that program. We were successful in identifying some of the people who became team members in our Fab Lab, but we realized that some of the requirements that or the relevance of such program to our community is not apparent, or we are not able to achieve, because most of our applicants were either full-time students or employee and employed, I mean full-time employed, and they were not able to commit the time and the resources or even secure funding to complete the program. And we ended up with many people spilling off the 6 months period of the program, and basically that caused a lot of difficulty and implications on the impact and reaching the KPIs by the Fab Lab and the funding entities. So then we decided to start the Fab Academy Start program, which in a way is basically started as a way to identify the overcome the challenges we face, and basically make sure that the program is sustainable and we are able to achieve certain goals that are set by our funding entities, which in this case is the Labor Fund in Bahrain, which is responsible for the empowerment and skill development in youth. So we know that some years ago, the pre-academy program started, and it was championed by Francisco Sanchez, and we took actually inspiration from that program, and we designed a program that would take some of the content over the weeks from Fab Academy and divide it into multiple modules. So one module will focus on the fabrication and the project, while another module will be mostly on electronics and the applied projects or applied knowledge. And we actually followed all the assessment documents of the Fab Academy, and we used the issue tracker as a way to instead of new eval, to evaluate our students. We have created documents for the students to as notes, and well, as an outcome, we had so many successful projects that came out of this program, as you can see. And this year, we had 2 students who are joining the full diploma as a proof of concept that the students could plug in back into the final diploma. And as a problem we also faced was the scale. We couldn't scale our programs to reach communities. So we started looking into programs that reach vocational schools. So the Fab in a Box was one of those programs, but we also, even though we created a program and a pop-up Fab Lab in a vocational school, we had an issue of getting to the students. And basically this is how the map looks when you are trying to reach from teachers to students. And there is a lot of bureaucracy channels that we have to navigate through, while in the later versions, we tried to come up with a version that overcomes such hurdles and directly reach to educators in a borrowing model. And I think this program plugs in with all the Fab Learn program, and I think it also a way of identifying our local requirements as far as schools and the gap that exists between the public schools and the private schools in terms of access to ICT technology or the access to digital fabrication tools. And if you need to learn more about the program, the Fab Lab link is the following, and the program I just mentioned, which targets educators and teachers in the public sector, is called spark.fablab.bh. Thank you.
Great. Like all of these, great to see all this progress. On to Tom. Tom Dubick. Let's see, Tom, I had muted you. Can you unmute? We're not getting audio, Tom.
All right, there you go. You can hear me now, right?
Now we hear you.
Can you see my screen?
Yep. Go ahead and present.
Sorry about that. Let's go.
All good.
Okay. All right, great. All right, thanks everybody's patience. So these are all very exciting. All the activities at the K-12 level. In fact, all the Fab Academy academies, all these things from biology, etc. What I'm going to share with you is a strategy if you're not trying to necessarily reach every student, though we do reach every student in, say, the 6th grade. But for those schools that have real interest in engineering and you know you're going to send students on, you can offer Fab Academy, the full-blown version, and there's some real advantages and things that kids can get out of it that's more than just obvious. All right. And of course, we're running a CNC machine, and you can hear the voice in the background. I apologize. So the next thing we're going to do here is we're Charlotte Land School. We've been in the Southeast. We've been doing STEM before there was a term for it in 1989. We graduated. I graduated with some other teachers back in 2016, and we've been offering Fab Academy when one student said, hey, could we do it? And that's what we did. So generally every day, if you can see all this decals through the years, each row of that shows different classes and their starting at the top all the way down the bottom. Yeah, that's Neil at one point and everything. Those are the stickers you do with the vinyl cutters. So we've had brothers, sisters, fathers, and sons even do it. We've had high school alumni that went on to college, went on to engineering, and then they, pardon me one second. All right, sorry about that. Now I got that background now. So we've had fathers, sons, sister, and brother do this team. Everybody's come on. It's become a special part of our school. I know, by the way, in Turkey and in China, there's 2 high schools that are trying to do what we're doing right here as well. But you know what? It doesn't just, if you offer Fab Academy at your school, which I'd encourage folks to do, the full-blown version, it benefits not just the Fab Academy. All our kids get that expertise. The kids who can't participate, for example, are in sports or in theater that day, because when you do this, the kids have a full day of class and then they have Fab Academy. So they really don't have time to be in anything else. And that's one thing we really encourage. So if you think about an evolution of STEM program, in our humble personal opinions, STEM 1 was robotic kits. STEM 2 is digital fabrication, which is Fab Academy. The extreme of that, or the high end, I would say, of digital fabrication. Then finally, our internships. And by doing this digital fabrication and by sharing this expertise, our kids are now doing college internships at our high school. So, for example, so who should take it? Students passionate about some aspect of digital fabrication, students who can cope with the academic demands of Fab Academy. The key thing being passionate. The academic demands is not just Fab Academy, it's keeping your grades up in high school. And it's getting parents and students to understand not everyone will finish. Also, too, an unintended consequence for this, which is great about this, they develop grit to be successful in life. Frankly, was very recently, a group of my students submitted some work that wasn't his best work that we've done at this lab. And so this was a great opportunity for them to learn to that, because there's no grade in my high school with this. This is totally independent in terms of grades from the high school. So they learned, hey, we didn't work as well as maybe we should have. What are we going to take from that? How's this going to happen in life? How do you respond? And you felt more like a coach than a teacher at that moment as I challenged them. So I think that grit part of this, and that's feedback we get from students, is very helpful. Also, while Fab Academy may or may not help you get into college, honestly, I don't think it really helps. Once you're there, it really helps you in college. So it's this contradiction. Colleges don't know how to measure it, and therefore they don't know what to do with it. But what our students that go into college are able to get into clubs, are able to get leadership clubs, which then allows for more internships. You know, as a rule, our high school produces more electrical engineers than most schools. If you see here, they either become electrical engineers, or this tattoo is one of our earliest graduates who was so changed by Fab Academy. He got his first tattoo, and this was in memory of that. And he did that right after he graduated from high school. And it was all about it. It was Will Knight. It was the work he did. And he got a tattoo celebrating that, which is kind of tells you how life-changing that is. We have students that are now going to, in Duke and Chapel Hill, so good programs, going in internships where during the internship, yeah, you did this at Duke, you did this at Carolina. What is about this Fab Academy? And they talk at great length about what they're doing in Fab Academy. It's the work they did in high school. So again, I'm encouraging everybody to think about doing. On the left, these modular gardening systems and this disability forewarning are all projects that have been done in the past that now these students are doing internships right now. One company, we have one student here, 2 students, Angelina and Adam, both working for Rhythm Link now. We are asking where was their work getting patented, and the company's basic response has been, well, we kind of think of it as a industrial secret. We're not sure we want to give it that with your information away right now. So they're doing some really good work. And that's because they've been trained up through Neil and through all the instructors here at Fab Academy. Finally, we have students that are getting A-round funding freshman, sophomore years in college because they know how to digitally fabricate and to bring an idea together. And that's really powerful once you now tie in AI that can help you get the software going off the ground. So now you have hardware and software coming together pretty quickly. And for example, during the pandemic, we made 114 face shields along with the local maker community and the UNC Charlotte. It's originated here at our lab. That now our students are now working with those hospitals their senior year and working on projects. So they're, because I would tell you, I believe 17, 18-year-olds are ready to work on real world problems. It's the ultimate in STEM education, which is project-based learning. That should be both engaging and rigorous. And
Tom, 1 minute warning.
There, I'm finishing her up right on time, Neil. Neil says turning on a single LED using a board that you designed in your mill is life-changing. I say that's true. If that's true, which it is, then Fab Academy is a 3-meter strip of neopixels. Thank you very much, folks.
Great. Thank you, Tom. Okay, now we'll go on to Rodney.
Awesome. Can everyone hear me? And can we see the slide? Awesome. So I'm Rodney Williams. I'm the program manager for education and outreach with the Fab Foundation. I'm going to talk to you all about some of the educational and outreach projects that we are doing so far this year and in the past. Let's see. So as you all know, we are in the 4th industrial revolution. So what is important with this is we're trying to make sure that the students that we work with and educators are preparing their students for this workforce and the evolution of that. Some of the various skills that you will see in this revolution or this industry is automation and robotics, additive manufacturing and 3D printing, as you all know, AI, Internet of Things, and cloud-based technology. In terms of, I have the opportunity to work with several corporate partners. One of our newer partners is the Caterpillar Foundation. Caterpillar, they're a manufacturer. They do machines, big machines for mining and things like that. Caterpillar wanted to do something to engage not just teachers, but also students. So we did 2 projects with them. One was in Perth, Australia, and then the other one was in Texas. So in Perth, Australia, we worked with a partner called Data. They work with their technology organization in Australia. So we got to train 30 teachers with the digital fabrication tools, and they got to take these tools back to the classroom. So all 30 teachers were able to get a 3D printer, vinyl cutter, and a set of electronics, and they were able to take these back to the classroom and engage the students. We had the sister program in Texas. This was held at University of Texas, Arlington. They have an amazing Fab Lab. If you haven't seen it, you should stop by and visit. They're doing great work. But within Texas, we had the opportunity to train 50 educators. The response and testimony from the educators was amazing. A lot of them said this was the best PD that they have ever experienced. And they were just so excited to be able to have these tools. They've heard of these tools, they've seen them, but they never had the opportunity to utilize them. So this was such a fantastic experience for them. We also partner with the Chevron Corporation. Over the last 14 years, Chevron has supported 20 Fab Labs and mobile labs. 3 of the newer labs there's one at FAMU and Fort Valley State University, which are historically Black colleges and universities. And then we have the Central Coast Mobile Fab Lab, which is a culmination of Hartnell College, California State Monterey Bay, and then also the Monterey County Office of Education. So they come together to form the Central Coast Mobile Fab Lab. And these mobile labs are able to reach rural areas that are underserved and not able to have access to these tools. So it's definitely life-changing for those students. Another thing that we have is our platform called Scopes. So if you're not familiar with this, I'll put the link in the chat. But this is a space for educators or folks in the network to post lessons. We would love for you all to post your lessons. There's so many great lessons that are on here already. Also within the Scopes platform, Chevron has funded our Chevron Fab STEM Fellowship we're in our third year now. So what this is we select fellows, they get a $10,000 stipend to spend on whatever they would like, but they have the opportunity to travel to 2 labs, one in the US and one global lab. Within that lab, they spend 3 days in the lab working on a lesson with the host site, and then they do a podcast. And then we've had this year we'll have 3 fellows, and we've had several hosts, about 40 host sites this year. So that's great. So the fellows will get to travel to these spaces, but this is a great program. You can learn more about this on the Scopes website. So I know this is our new initiative that we're working on called Fab in a Box. I don't know if you all were in Mexico last year, but we unleashed this giant, massive cart. So we went back to the drawing board. Now we have what's called it's more of a fab wall. So this wall it connects and it's interchangeable. It can separate a classroom. So within a classroom, you can have your own type of fab space in that room. It's also accessible in terms of students, if you have younger students, if you have students in wheelchairs. And this is, we want this to come in at a low price and a low cost and high impact. So this wall has a 3D printer, a laser cutter, and a vinyl cutter on it, and it comes with a computer, and it comes with lessons that you can find on the Scopes website. So this is something we're excited about. This our team really has been working hard on this. Luciano and Abigail are kind of leading the charge with this initiative here. If you guys need more info on us, you can scan these QR codes. Also, I'll put the Scopes DF link in the chat. But that's what I have. So thank you.
Great. Thank you, Rodney. On to Jean-Michel.
Thanks, Neil, and I'm happy to follow up after my wonderful colleague Rodney. You can share the website, Neil. I don't have any slides. So what I'm going to talk about is not going to take very long because it's in development. It's not yet there. We hope that we will have something for you probably after the event in the Czech Republic this year, Fab 25. Maybe open to a select group of people who want to be part of a trial version, and then hopefully we'll start a more complete version in 2026. There's another website also, I think, Neil, that Luciana linked, but this one does too. Works too. The idea of this is something that I wish I had when I was younger, and it actually came from the moment we were in Bhutan. Where in Bhutan, actually, they asked if we could do additional educational programs, similar to Fab Academy, but shorter in time. And so the idea is to develop month-long programs around what we call 21st century vocational skills. So these are sort of more modern subjects that all of you have heard about and that I think a lot of people are interested in, but that not a lot of young people for sure necessarily know sort of a lot about or understand what it really entails, right? So the idea is to create month-long courses that run one after another and that basically never stop. So I think, Neil, you always refer to it as the O'Hara landing pattern. So the idea is that you can follow one of these in a year, you can follow 12 of these in a year. It's really up to you. And the ones who get a lot of traction, we may expand them. But initially, the idea is to have all of these take form as a 1 month long course that in many ways is very similar to Fab Academy. So there's going to be hands-on elements to it. So hands-on when it comes to, for instance, cybersecurity. Obviously, doesn't mean that you need a laser cutter, but it means that you need a server, that you need the tools to sort of set up protection for said server, et cetera, et cetera. So it does have a lot of components that you actually need to actively engage in. And we also wanted to set it up in such a way that it's not something you can just do at home on a couch. We want you to be able to do this in labs with peer groups, where you also work together on group projects as well. So it's not something you can do on your own. It really follows the structure of the Fab Academy in that sense as well. And again, what I'm very excited about is that I wish I had this when I was young. just to learn really what all these exciting new fields of science and research and work entail, what artificial intelligence really is about, what way robotics is going to go, what quantum technology actually means, how to use biotechnology and do precision agriculture and those kind of things. So for now, we're working on setting up some trial versions. If you're interested in this, please reach out to me. And hopefully we'll be able to roll this out more extensively in 2026.
Okay, so a few notes on this and then a few final notes. This started when Bhutan has a problem. It has all sorts of needs for skills, and meanwhile, young people are leaving the country, and the vocational training is, 19th century, very traditional skills. And so they asked if we could help with their vocational training. I gave them a menu of possible topics, and they said we want all of them. And that's what led to this model. And so these are intense 1-month exposures. All of them add up to a program. But then also part of the idea is this ever-rotating group of global leaders. This is an incubator for new classes. And so 1-month units that really get traction could expand into full Fab Academy programs. So that's one of the exciting new initiatives I'm working with Jean-Michel on. Another one is distinct, and this is, I'd fault us. We're doing a lot of things well, but I'd fault us on, after we bring you in, train you, give you skills, you can fall off a cliff for next steps. And so in particular for incubators, which could be for-profit, but also non-profit, generally you leave us and you need to go somewhere for that. And I want to build on the network for incubation. And so this is a growing dream team of people who have made significant success running up businesses and organizations to bring the incubator to you rather than you to it, as a globally distributed incubator. And that's another program we're in the launch phase for. Let me step back now to note Fab Academy is a global effort. For those who joined late, somebody unplugged Spain, which is why Luciana is not here. But she coordinates everything very ably. Julian runs our IT. There's a lot of support that makes it possible through the Fab Foundation with Sherry and colleagues. Each of these classes has global teams of gurus to make clear what makes it possible. Going forward, one of the things I'm currently working on is, it's been fuzzy what is and isn't Academy. As this matures, we want to be more rigorous about it, both to better filter and support and bring in resources. So we're going to be doing an overhaul of the Academy site. And here's my definition of an Academy class. It's empowering knowledge guided by global leaders in a network of connected local labs, peer-to-peer project-based just-in-time learning, student work gets documented, skills-based portfolio. While it's informal, we're very formal about assessment, with rigorous assessment done both locally and globally. Clear agreements for student lab course responsibilities. Courses do annual report. There's annual student survey reviews, periodic reviews of these classes. The courses use shared infrastructure. Central to this is, it's not philanthropy, that there's models for financial sustainability. There may be bootstrap phases to reach that, but this is designed to be financially sustainable, not rely on charitable funding. And let's see, and a process for Academy review of new course plans. We sort of backed into doing those for the things you've heard about today. Going forward, we want to be more structured about how Academy grows to take advantage of all of the opportunity. So these are all parts of an overhaul we'll be doing of Academy program and Academy site. So with that, 4 minutes left. Any questions or comments? I mean, I'll start with a comment that it was a pleasure to see all of the energy, invention, and every single thing you heard today was not centrally planned. There, at no point was it top down or a room full of people declared each of these should happen. Every one of these was sort of spontaneous opt-in interest, which is wonderful. Any final questions or comments? Frosty?
Yeah, I find this interesting about the Fab Futures. Will it, do you have like further information when it will start, or will that, will you see that in the Fab event in Czech?
Yeah, so stay in touch with Jean-Michel. This could become the most important of all of these programs, given the demand we're seeing. Right now, too many of these are limited by my schedule. So one of my goals is to obsolete myself and fan out. So, but right now I'm very involved in, we have a group of starting sites opting in. We're lining up some initial faculty for initial units. The goal is to do a trial of like 3 units this fall. And if you want to participate, reach out to Jean-Michel to join that.
Okay,
I
thank you very
added
much.
you to my list, Frosty. I'll let you know. And I don't understand how you could think that we would keep this secret from you, but we'll talk about that some other time, I guess.
Thank you very much. This is very good.
So about the Fab Futures, since it's modular, is there any further thought about maybe obtaining this kind of like micro credentials that they can be more universal and not less location based?
Yeah, that's a trigger. Let me mention for people not familiar, early on, a question was accreditation, and I tried to accredit Fab Academy. And what we ran into is accreditation is geographical. You accredit a place. There's no way to accredit a network. But the accreditors gave us helpful advice, which is they said, pretend, meaning make up a credential, make it rigorous, and eventually they'll catch up to us. So what has happened fairly spontaneously is our global credential is now recognized in lots of local crediting systems as overlays. And each time we do it, it makes the next one easier. So that's been working in Fab Academy. For Fab Futures, it's a good question. We'll be doing the same rigorous assessment of each one for the monthly units, and I expect we'll have some recognition of doing a whole year of these programs. I'm not sure if we can go further than that. It's a good question. At some point in our future, likely is to go further into, we've never actually like accredited in any way Academany itself. It's always the local nodes, and probably as it matures, we're heading towards that. Generally, what we found is people never ask who accredited Fab Academy. They want to know what the students know how to do. And in many of these areas, just the accreditations aren't even all that relevant, although it's relevant for things like funding or admissions. So very much a work in progress. Final questions, comments? If not, oh yeah, this is to me, a wonderful span from early K-12, teachers in formal classrooms, informal Fab in a Box, where the box is the teacher, through K-12 to college level to beyond, and a lot of really exciting, interest in accreditation. Lots to talk about at Fab 25 on that. We'll have working groups on all of these. And so overall, for follow-up, I'd say Luciana, who couldn't join, is the point node coordinating all of the people in all these programs. She's a great central point. Specifically, again, for all the interest in Fab Futures, stay in touch with Jean-Michel. We'll be sharing and discussing all of this at Fab 25. And again, I'll close with what I said a minute ago. I was really struck today at all of the energy, invention, and how every one of these was kind of spontaneous, bottom up, and then we're trying to build on that interest and passion to, at heart, harness the world's greatest underused natural resource, which is the brain power of the planet. Thank you all.
Thank you very much. Thanks a lot.
Thanks, everyone.
Thank
Takk
you,
kærlega
guys.
fyrir. Thank you.
Thank you.